Manage supply chain with a focus on sustainability. Introduction. The True Textiles have development sustainability in the textile chain. These ambiguous goals include zero waste, zero harmful emissions, operating with renewable energy sources, designing closed-loop processes and products, transforming transportation to maximise efficiencies, community engagement and the development of the new business model that joins economic, environmental and social impacts of the product development process. Aims, environmental considerations and sustainability. Given the increased market demand for environmental considerations using green technologies, reducing carbon footprints and employing sustainable practices, the textile industry continues to advance technologies towards this goal. Sustainability has many definitions, but the basic principles and concepts remain constant: balancing a growing economy, protection of the environment and social responsibility, so they can together lead an improved quality of life for ourselves and future generations. Life cycle. The following 5 headings describe the issues that make the life cycles of textiles and clothing unsustainable. 1. Water, misappropriation and inappropriate use, excessive use, contamination. 2. Chemicals, profligate use of pesticides and herbicides in agriculture and of toxic chemicals in production. 3. Asset stripping of non-renewable resources, including energy sources under evaluation and non-regulation. 4. Waste. Too much is destroyed. Systems need to be developed to recycle all non-renewable or compost renewable. 5. Transport. Life cycle project aims. Ecologically friendly textiles and clothes need to be fit for purpose and affordable. For the project life cycle, we need the following. What kind of raw material? Raw material processing, harvesting methods, yarn and cloth production, garment construction, finishing, embellishment, packing, presentation, dispatching, transport, packing, protecting, local or global distances, etc. Services, sales, industry, infrastructure, where customer and textile meet, local or global, transport, energy, and so on. Use laundering and drying, energy, toxicity, gas emissions, etc. Reuse, recycling, disposal, transport, energy, gas emissions. Life cycle for research and development. Every good invention starts with an idea. Within textiles, the emissions are sustainable competitive advantage that will add actual value, reduce cost, and or create or increase market share. To reduce any uncertainty, we have research followed by development. The life cycles of these 2 events can be summarized as follows: exploration, evaluation, test and analysis at lab level in the pilot stage, commercialization, capitalization. It is the assessment of alternative options for application of the idea. As a part of the innovation process, protection of intellectual property should be considered. Patent protection. Corporate social responsibility, CSR, and its issues. Social responsibility is one of the 3 components, basic principles, and concepts of sustainability. US EPA 2008E. Companies manufacturing textiles need to consider corporate social responsibility, CSR, as part of doing business. Common elements of CSR are A. A reliance on meeting or exceeding the letter and spirit of legal, ethical, commercial and other business requirements, and B. A focus on the impact of the company's operations, products and services on people, communities and the environment. Issues of CSR in the supply chain are the following. 1. Human rights and worker safety. 2. Marketing integrity. 3. Environment impacts. Eco-label for textile products. US Federal Trade Commission in their 1998 Green Guides on Eco labels were fairly simple and straightforward, e.g. reusable, non-toxic, biodegradable and compostable. Today, the concepts and terminology are much more complex, e.g. carbon offsets, renewable energy credits, cap and trade and carbon footprint. The concept of an eco-label for products of commerce continues to evolve. The term textile ecology is easier to comprehend if explained in three parts: production ecology, human ecology and disposal ecology. The modular approach to eco-labelling for components within the textile chain, according to requirements in Criteria Ecotext, are at this link. Applications of sustainability in the textile chain. The applications of the sustainability through the supply textile chain are the following. The production of cotton using organic farming practices seeks to maintain soil fertility, to use materials and techniques that enhance the ecological balance of natural systems, and to integrate the parts of the farming system into an ecological whole. Organic is a labelling marketing term. All the fibres as organic in the US must meet the USDA NOP 2002 rule for crop production. For cotton to be sold as organic cotton, it must be certified by an independent organisation that verifies it meets or exceeds defined organic agricultural production. Applications of sustainability in textile chains. Sizing is the only operation that may have some environmental concerns in weaving. If starch is used for sizing, it is normally removed with enzymes and scouring. Starch breaks down during the enzymatic treatment and is removed by washing. It consumes oxygen, thus lowering biological oxygen demand or BOD, in the wash-off water. Chemicals allowed and prohibited for use in preparation, dyeing, printing and finishing of organic cotton textiles. Global Organic Textile Standards, Organic Exchange Guidelines, Organic Trade Association. The chemicals were synthetic chemicals allowed, non-synthetic chemicals allowed, chemicals prohibited, conformant dyes, dyes not allowed. Applications of sustainability of textiles. Certain applications of nanotechnology are especially relevant to textiles and consequently have important implications for sustainability of textiles. A highly relevant aspect to the textile sector is the high specific surface area of nanomaterials. The effectiveness of nanoscale coatings and finishes on fabrics is a key area for sustainability in textiles and fashion, for example, by reducing the effects of wear from abrasion and reduction in the need for laundering. Other characteristics where nanotechnology can be an impact on textile sustainability and rescue wastewater include the improvement of dye uptake through surface fibre effects, preventing of fading by loss of colour through exposure to ultraviolet, UV light, coloration without dyes using, for example, gold and silver nanoparticles.